direction of torsional shear stress and the surface on which it acts. And then I would like to introduce one movie that I love. The topic is Twist the Choke. And completely it's written in Japanese, so that I will give a talk in English. The choke is said, and this person will twist the choke and block. And please watch the broken surface of this structure. And 45 degrees spiral shape is observed as the broken face. And he tried many times. Yeah. This is another choke, white choke. Another white choke is used for twist. And the broken face is, roughly speaking, almost same. This is the something like a spiral. Spiral shape is observed at the part. And next, he said he prepared the car choke and twist. Roughly speaking, the spiral shape is observed, and honestly speaking, the white choke and car choke is different. The content of the choke is slightly different, and that really affects the stiffness and the mechanical properties of the choke. So the broken force and the broken face will be changed. But theoretically speaking, almost same. Okay, so you can understand he tried 4 chokes, and then for all cases you can find the spiral broken face. Okay, for torsional shafts, this movie is very important. If we change the materials, then this broken face is changed, shifted. But the mechanism, how the force and stress will be applied for the structure is the same. So for understanding how the stress work in the choke, in the cylinder or in the cylinder, will be understood from this movie clearly. And first I give 5 minutes, like 5 minutes. Please solve these problems. Okay, for review, please solve this problem. You will learn the equation of this problem, I think. So if you cannot understand how to solve it, then please open the note and find the equations that you learned in the last week especially. Or please open the text and find the equations related to this. Or find the figures that are similar to this problem first. And other time, please read the answer and understand how to use the equations. Okay, anyway, I will give 5 minutes, so the answer will be given from 441. 441. I'll give an answer. 1.5 degree. And from this equation, you can get the value of gamma AB. And tau AB is calculated from this equation, and G is given. So you can get the value of tau AB. And you can determine the shear strength in both CD and EF by the same way. So the angle between G just a moment, please. I'm sorry. And Steve, from these angles, this structure will be rotated, and here rotated. So same equation will be used for the same equation will be applied for CD and EF. We got the value of tau AB like this. Okay. From G and gamma, you can get the tau AB as tau AB is 52 pounds. And you can get the tau CD and tau EF respectively. The each phi 3 and phi 3, and each R2 and R3, and the length between CD and the length between EF is already fixed. So from these ones, gamma is calculated. So from gamma and Z, you can calculate the tau. So that not only tau AB but also tau CD and tau EF are calculated like this. Okay. Next, please solve this one. And we solid cycle steel shaft BC is securely attached to two whole steel shafts AB and CD as shown. Determine the angle of rotation of section at D with respect to section at A. B, the maximum torsional shear stress in the shaft. Okay, so please calculate A and B in 5 minutes. I'll give you a hint on A. In fact, the equation should be used um, to get the angle of rotation. Okay, and this time 1, 2, 3, 4, 4 torques are applied for this structure, and the angle of rotation, the rotation torque will be different between AB part, BC part, and CD part. So we should estimate separately. So in the AB structure, this is the internal torque between AB. Please draw this kind of drawing, please. As a test and when you solve such problems, then please draw many drawings by yourself. This drawing is given in the text exactly, and please draw additional one that will support the understanding how you solve. Okay, so at the time, the torque in the structure of AD is different. When the torque will be changed, where the torque will be changed. Yes, here constant torque is applied A, B, C, and D. So please draw like this. A, here the torque is applied, and B is this kind of counter torque is applied. So the torque is drastically down to minus 300 kips. And at C port, 200 inch kips is added for this way. So minus 300 is changed into minus 100 as C port. And additional D 100 and this direction torque is applied. Then 0. So the A and D both are 0. But the inside between A and C, such torque is changed at B, C, and D part. Okay. So internal torque is known from these drawings. And what kind of equation should be used to estimate the angle? You already learned. Please check this page, page 217, and as an equation. That is the inertia equation. I'm sorry. This is the important equation to get the angle. Okay. You already learned this, and this is the integrated. Then the phi between the start to end will be estimated by this equation. Okay, and T is constant, G is constant, and I is constant between AB part, BC part, and CD part. Why? Because I will be estimated like this. And hollow steel shaft. This is also hollow steel shaft. And this is perfectly solid circular steel. Okay. So the I is changed. IP is changed. Okay. So between AB and between BC and between CD, T, G, and I are constant. So it is very easy for you to integrate this and get a phi from this equation. And when you calculate the phi, at that time T is given from this drawing, and I will be estimated from this equation. Okay, and IP is here, and low and DA should be estimated here. And DA is here, so that low by D low. Ni pi low is the length of this circular, and D low is the thickness of the part. So that this area will be calculated as knee by low by d low, like this. And AB and CD, these are the same structure, same hollow steel shaft. So the IPAB equal IPCD, and then this I will be estimated like this, and IPBC is estimated like this. Okay. The diameter is 4 inch, and the diameter of the diameter of the in a hollow is 2 inches. So the radius is 1 to 2 for this structure, and for BC structure, the center is 0, and the outer diameter is 2, and this is solid, so that it must be integrated from 0 to 2. So this is the difference between IPBC and the other two hollow steel shafts. And you can get the value on both IP. So that T is known, I is known, and G is given. So you can estimate the phi from this. Okay, and this change like this. Okay, TAB and LAB or GS by IPAB and so on. And from G1, 5BA, 5CB, and 5BC are calculated like this. And the angle, so the problem is angle of rotation of a section at D with respect to a section at A. So the total angle between A to D should be calculated for A, so that we add them. Then phi dA should this should be calculated, and you can get this value minus 1.95 degree. And next one, do you calculate now? I will give several means. So please use this equation and get the value, please. I will give 2 or 3 minutes for calculation of this. calculate these ones. And the problem is estimation of the maximum force of this structure. At that time, we compare after calculation of these three taus, tau AB and tau CB and tau DC are calculated like this one. And from this one, you can find this tau is a maximum, so it should be calculated. The answer. Okay. For this problem, literally the similar equation is used for calculation. Anyway, please understand the difference from similar equations, and what kind of equation should be used should be understood after you calculate many times and many problems. You can find the difference between them, and at the time you can use correct equation to get correct value. And it is the last program of this class, and so I'll give like 20 minutes for solve. And around 10 or 15 minutes later, I will start to give a hint of this problem. So please start to solve this. The problem is a two-hole aluminum shaft securely fastened to a solid aluminum shaft and loaded as shown figure C5.9. Point E is the inner surface of the shaft. If the T equals 300, it keeps in figure C5.9. Determine A, the rotation of the section at C with respect to rotation the wall at A. The B, the shear strain at point E. Please solve these problems. register your attendance by using this password. Now open the once new door of the material mechanics fundamental page, and please register your attendance, please. Most students register the attendance, so I like to list as the practice. Yes, and now I'll give a hint. Please read this one. Okay. For this problem, only this key or this talk is applied here. Okay. So the total moment between this structure should be zero. I mean, A fixed completely, and D on the other hand, D fixed completely. So that T is applied here. However, this structure doesn't move. So the total moment to this structure should be zero. So here T is applied. On the other hand, this TAB applied here. Repulsive torque TAB is applied here, and repulsive TBD is applied here. And these T's should be balanced. If it does not balance, then this structure will be twisted. However, in this case, A and D are fixed and completely, so that a total moment must be zero. Okay. And geometrical condition, physical relationship, this is very important. And phi AB equal phi BD. Here the torque is applied, so that BD is twisted, and also BD is twisted. The angle between AB should be equal to the angle of BD. Okay, so the A is fixed, and B is twisted, rotated. Then the angle between BD must be equal to angle of BD. If that is not correct, D or A must be moved. However, that does not happen, so that phi AB equal phi BC. From the physical relationship, this relationship must be okay. So, from this equation, you can get these values. Phi AB and phi BD. This can be calculated from the equation that is learned from the former problems. The problem we solved before these problems, we use these equations. here is the structure, AB is the constant. So that we that is expressed like this. On the other hand, 5BD, this is composed from BC part and CD part. So the I is different. Okay, this is a hollow cylinder, a hollow shaft, and this is a solid shaft. So for example, the inertial I and so on are different. So we still compare these matters. So that at the time we split as C part. So we compare BC part and CD part separately, and after that the body will be combined together, and then the 5BD will be calculated. From this concept, 5BD will be expressed like this. Okay, from here, how do you calculate? Is it possible to calculate further? I will give several means again. Please keep strobing.
めっちゃ楽しそう。マジ？いや違う、今トイレ行く。
あれ、みのべさんとあれ食おうって言ってるけどどう？
え？
あれ、油そばをお持ち帰りしようと思ってる。ワックン食べる？
あ、鶏肉でも。
俺らが取りに行った
あ、いいよ。お願いしていいかな。でも俺、随分忘れましたね。
8時ぐらい。ここに
頼みますね。
Okay, this is a question about talk, and this is a question about phi that I introduced. So that we will use to get a full calculation. And before that, we estimate the IP from the definition. The definition is already shown in the former slide. That is, according to this one, this is the equation formula of IP. And IPAB equal IPCD. For the AB part, this is the hollow shaft, and CD part, this is also hollow shaft. And then the length and the diameter of inner and outer diameter is the same. So the IP of AB part and IP of CD part is the same. And this is the outer diameter, that is 2, and this is the internal diameter, that is 1. And so we can get the value of IP of AB part and CD part respectively. And on the other hand, for BC part, this is the cylinder, no hollow. So that must be integrated from the 0 to outer surface, that is 2 for this case. Just a moment, please. I'm sorry for my sudden interruption. I'm sorry. And anyway, you can get the value of IPAB and IPCD and IPBC respectively. And this equation that I show in the former slide. Here. And d phi AB per d phi AB dx by LAB, or d phi BC dx LBC plus d phi CD dx LCD. And and this is changing to like this. Okay. Um, I should back. Um, this d5ab per dx lab equals blah blah. This is shown. Uh, ここでいいのか。This is the basic equation, and this is the integrated one, phi equation, not d phi. And this is very easy for us to calculate the phi. So this is will change like this. Okay, and TAB. And we get and TAB and TBD it should be calculated from this. As I told, this is the equation between T tau and TAB. This is not known, and TBD this is also not known. So the TAB and TBD it should be calculated from two equations. And from these ones, you can get the value of TAB and TBD respectively. That is 211.92 inch chips, and TBD equal 88.07 inch chips. For the from this one, TBD T is known, and L is also known, and G is given, and I is calculated here. And then you can calculate the phi AB, phi BC, and phi CD respectively. So that finally I will give the 5 minutes for this estimation, and additionally please solve the B. complete the calculation, I think this is the answer. If this answer is not correct, then please contact me. And phi AB, this is calculated from this equation, TAB per GIPAB by LAB. And then the value is 1.24 degree. And next, phi BC is TBD. Oh, this is very important. I should explain more about this equation. Here, not TBC, but TBD is used. And here's TBD and here's TBD. Why? That is very simple. Here T is act and for please imagine the internal cut between AB part and the BC part and the CD part. And then how the torque work in the structure. In AB part, that is very simple. Yeah, TAB, constant TAB is applied here. And how about BC and CD part? Yeah, external force, only T is applied here, and repulsive force will act at A part and D part. So if we cut imaginary cut here, and we estimate this structure, then due to this repulsive torque that is active on D part will be appeared in imaginary cut of CD. And how about BC part? We estimate this structure, and then only external torque is applied here, and that will continue not only CD part but also BC part. So TBD TCD equal TBC. That must be constant. Okay. So we explain it as TBD here and here. Oh no, that is not correct. This one is correct. Yes. From the equation, TBC is okay, but for this case, TBD is TBD should be used because TBD from between the structure of the structure from B to D part, that T must be constant. And so the TBD should be used. And for phi BC equal TBD per GIPBC by LBC, then the value is 0.723 degree. And for final one, phi CD equal TBD per GI low BC by LCD, that is 0.51 degree. Phi CA equal phi CD. So the this one the 0.51 degree. And the problem of B, we should estimate the shear strain at point E, and how low equal T low per IP, and so the tau E equal TBD. For this T, for this case the TBD, and low should be the gamma, and the IP should be the IPCD, and then the tau E equal 7.48 tips. Okay, this class is over now. Okay, from next week another topics will start. So please continue reviewing, not only for this material material mechanics. Sorry. Not only for this material mechanics, but also other classes. And I'm sorry again for my son shouting. I'm sorry about that. See you. Bye bye.
Thank you.
Bye bye.